You may ask me why CUET. The question is really beautiful, and you should be learning and understanding the fundamentals of the ideas. So let's discuss this problem.
Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI MStat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So let's try out this problem of CUET. This is CUET 2023 problem 26. So I already shared this problem previously. I do not know how many people have looked into it. If you're in the WhatsApp group and if you regularly follow our updates, probably you have read it. But I really want to discuss this problem with you. CUET 2023 problem 26. It's from a multivariate distribution. It's a probability problem. Let's see what it says. So x comma y is a joint random variable. It's a multivariate random variable, bivariate random variable with probability mass function, let's call it PMF, as the following function. It's a bivariate, so the PMF will look like this. X choose y, 1 by 4 whole to the power x. Not only this, it should also be provided that what is the support, right, where this is actually holding. So you need to know the x values, you need to know the y values. So let's look into that. So the x values are 1, 2, infinity, like geometric distribution. And y values, interestingly, is still 0, 1, 2, x. That means so y is less than equal to x. This is something you should note right away. Because this is where usually problem solving can go wrong, because you do not observe this support. So the question asks the following. We are given this joint distribution, but we want to find the variance of y. That is the goal. What is the variance of y? Now, if you think about it deeply, you will feel that to find the variance of a distribution y, probably we need to find let's think about a few problem solving methods. Probably we need to find a few strategies. One strategy can be to find the distribution of y. The other strategy can be not to use the distribution of y, using something called LOTUS. LOTUS is a very interesting strategy that is mentioned in the Blitzstein book, Introduction to Probability. It says that if, let's say, you know the distribution of x, let's say x follows normal, 0, 1, you want to find expectation of x squared, rather any function of x. So how to find expectation of a random variable y? You find the distribution of y, and then you find its expectation, right? But what is LOTUS says, so the whole, the expanded form of LOTUS is the law of the unconscious statistician. How do you find expectation of a random variable y? You find, let's say, integration. Let's say it's a continuous random variable y, f of y dy. This is the PDF. Assume the PDF exists, and this is the y. You know that PDF may not always exist for a random variable, right? And this is why. This is over the support, let's say. Now, if the statistician unconsciously does that, expectation of f of x is nothing but integration of the support. Instead of y, since y is just fx, just write f of x. And since it's a distribution of x, it write f of the PDF of x. And this is the, okay, I should have used gx. Let's call it gx. Then also, this is actually true. In other words, you do not have to, you can find the expected value without actually finding the distribution of f of x or g of x. Do you understand? I'm repeating once again. It's saying that if y is a function gx of the random variable x, Then, to find the expected value of g of x, or rather y, you do not have to find the distribution of y. As you can see, that's the general method. You do not have to find it. Using to find the distribution of y, you probably have to do Jacobian and all these things, right? Which is quite cumbersome. Instead, if the statistician use the distribution of x and unconsciously, you know instead of just x, write gx in place of expectation wherever it is, this result also holds. That means this is, even if it's done unconsciously, it's true. So that's it. That's why it's called the law of the unconscious statistician. This term is taken from the book Blitzstein. His book is really good.
To book a trial class for your preparation courses of IITJM MS, ISIM Stat and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Stay tuned and stay blessed.